Here's some examples of looking at your negative exponents and how to apply them. So first we're going to do a few where we're taking each expression and instead of having it with the negative exponent, we're going to change it so that we're writing it with a positive exponent at the end. So for number 1, 4 to the negative third power. Well, remember that when we're talking about a negative exponent, it's really giving you a positive exponent if you find its reciprocal. So if you're looking at 4 to the negative third, we're going to leave it in exponential form, and we're going to write it as a fraction, or think of it as the reciprocal. Reciprocal meaning it's 1 over whatever you have. Well, I'm going to write 4 to the third. As soon as we change it into a reciprocal, the exponent becomes positive. So it'd be 1 over 4 to the third. And we're going to leave it with the positive exponent since that's what we were asked to do. You could have taken it further and done the 4 to the third and gotten a fraction without the exponent, but we'll leave that here for now. Alright, so number 2, next thing, a to the negative fourth. So it's the same idea, except now we have a variable as our base. But it's, like I said, the same idea. So think about that exponent. What do you notice about it? First thing you should see that it's negative. Okay, and then we want to figure out how to write it as a positive exponent. So same thing. We're going to think about it as the reciprocal, and we're going to write it as a fraction with the 1 in our numerator and our denominator as a to the fourth, but the fourth is going to be now positive, and that would be our final answer. So again, you're just writing it under 1 and changing the negative to a positive exponent. Number 3. 2 to the negative fourth, recognize that exponent is negative, so we'll make it 1 over 2 to the positive fourth power. And we're going to leave that as it is. Okay, so those are some examples of changing it into a positive exponent. Now let's look at some examples where we have a fraction or an expression, and we're going to actually make it into a negative exponent. So if I have 1 over 3 to the fourth power, I'm going to flip that. So again, find its reciprocal, which just means you flip it. So it would now become 3/4 over 1, or just 3 3/4. 3 to the fourth, but because I'm flipping it and it's being written in the numerator, it's going to be given a negative exponent. Number 5, 1 over 16. Now, this actually doesn't have any exponents in it, but we can write that denominator as a number with an exponent. So let's do that first. So let's think about how can 16 be written as a power? Well, let's think about what we can, what times itself, or maybe times a few more of itself to give us 16. So if I think about that, you could be given a 4 squared. 4 squared is 4 times 4, which is 16. So in this case, we're doing 1 over 4 squared. Now you could have also gotten a 2 as the base. So I'll write it here just so that you have it. It could also be written as 1 over 2 to the fourth. 2 to the fourth would also give you 16. So that would be correct as well. But if we want to write it as a negative exponent, again, we're going to flip those and give it and change our exponent sign. So the first one would be 4 to the negative second power, since it's going into the numerator, and I'm going to change the exponent to negative. If I change the other one we got, you could also write it as 2 to the negative fourth. Now it just happened that the numbers were very similar, the 4s and the 2s. That's not always the case. So really keep in mind what number you're looking for. And then for number 6, we have a variable in our base. It's the same idea. We're going to write m to the 5th as a numerator, and I'm going to change the exponent to a negative. And I would be done with that problem. So those are all finished. Those are just kind of ways to rewrite exponents knowing how to go from positives to negative exponents and vice versa. Now let's work a little bit more with them as far as simplifying. So we're going to use our other laws of exponents on how to multiply and divide with the product of powers and the quotient of power rules. Just remember that when you're multiplying and dividing with negative exponents, the same idea. You want to think about how you would multiply or divide a negative number. So for number 7, if I'm going to simplify this expression, we want to think about what happens when we multiply our bases. So our bases are the same. We have 3's as the base for each term. If I'm multiplying numbers with the same base, do I add, subtract, multiply, or divide those exponents? So think about that. If I'm multiplying the bases, what do I do with the exponents? And multiplying the bases always makes me add the exponents. So it's going to be a negative 3 plus a negative 2. So you want to apply your integer rules. When you're adding same sign, you're going to find the sum and keep the sign. So it's going to be a negative 5. So our final answer is going to be 3 to the negative 5th power. Now let's keep going since we're simplifying it. Technically, when you're being given directions to simplify, you don't want to have a negative in your exponent. So in order to do that, we need to write it as a positive exponent, which is what we did in the first examples. So I'm going to flip it, put it under 1, and make it 1 over 3 to the 5th. And then I'm going to take it a step further and actually do 3 to the 5th to figure out what my problem is. So I'm going to multiply 3 by itself 5 times, which gives me 243. So my final answer for number 7 would be 1 over 243. All right, let's take a look at number 8. Now for number 8, we're not multiplying our bases anymore, we're dividing them. So what does that leave us with? When we're dividing powers with the same base, do we add, subtract, multiply, or divide those exponents no matter if they're positives or negatives? Okay, our quotient of power rules tells us to subtract them. So it's going to be p to the negative 2nd minus negative 12. So remember our rules for this, we're going to keep the first one the same. We're going to change it to addition and make the last the opposite. So that's going to become a positive. When I'm adding different numbers with different signs, I find the difference. So it's going to be 12 and 2 is 10, and take the sign of the larger number, which would be positive for 12. So my final answer would be p to the 10th power. Now in this case, my answer ended up being a positive exponent, and I also have a variable. So this is as far as I can go for simplifying. Alright, so that gives you a bunch of examples to work off of for this lesson. If you have more questions or you want to go over anything else from the lesson, please be sure to come to office hours.